These are simple torque and centripetal force problems solved. Torque is the product of lever arm in meters and force in newtons. For problem 38, we're asked to find the torque produced by a 50 Newton perpendicular force at the end of a 0.2-meter long wrench. So our force is 50 newtons and zero point 0.2 meters is our lever arm. So multiplying those two gives us 10 Newton dot meters of torque. We repeat it for problem 39. This time the length has been extended, so our lever arm is zero point 0.5 meters. That multiplied by 50 newtons gives us 25 Newton dot meters of torque. Notice that because you extended your lever arm, you have more leverage, you increased your torque. Centripetal force, represented by F here, sometimes F subscript C, is equal to mv squared over r, where m stands for mass in kilograms, v stands for speed in meters per second, and r is the radius. So for problem 40, we're asked to find the tension in a horizontal string that whirls a 2-kilogram toy in a circle of radius 2.5 meters when it moves at 3 meters per second on an icy surface. So this is your simple pictorial representation of this problem where the toy is represented by the orange sphere. It's attached to a string, and so the force on the string is tension. The center of rotation is right here, and so the center directed force is tension, and that is our centripetal force. This is moving in a clockwise direction. Our radius is 2.5 meters, so the distance from where the toy is to the center of rotation is 2.5 meters. And if you have a way to find the speed right here to measure the speed, it would be 3 meters per second. So to find the centripetal force, we really have to find the tension. So we use the equation force is mv squared over r and substitute our values. 2 kilogram mass, 3 meter per second speed, and 2.5 meter radius. When you perform your calculation with numbers, we end up with 7.2, and the units are kilogram meter squared per second squared per meters. 1 unit of meter can be cancelled here, and so you end up with kilogram meter per second squared, which happens to be the unit newtons. So the centripetal force for this problem is 7.2 newtons, and that's because of tension. For problem 41, we're asked to find the force of friction that keeps an 80-kilogram person sitting on the edge of a horizontal rotating platform when the person sits 2 meters from the center of the platform and has a tangential speed of 3 meters per second. So pretty much the picture would look similar to this, looking from the top course, with your 80-kilogram mass and distance from the mass of the person to the center is 2 meters and the speed is 3 meters per second. Your source of centripetal force here is no longer tension, but the force of friction. So we would solve for that centripetal force, which is force of friction the same way, mv squared over r. Our mass is 80 kilograms, our speed is 3 meters per second, and our radius is 2 meters. We end up with 360 newtons. So the force friction is very large. It's a value of 360 newtons.